Hi, Assalamualaikum warahmatullahi wabarakatuh. So today we are going to continue our lesson on subtopic 7.2, factors affecting the rate of reaction, to be exact, the factors of temperature and also catalyst. Alright, so the third factor affecting the rate of reaction is temperature. For information, this temperature is affecting only the reactant is in aqueous or in liquid form. Okay, so when the temperature of the reaction increases, the rate of reaction also will increases. At higher temperature, the particles of reactant have more kinetic energy and move faster. So you have to relate your explanation of temperature with kinetic energy. So if you have a high temperature, the kinetic energy of the particles also increases, so it will move faster and it will produce a higher number of collision, so the reaction also will be faster. So theoretically, the rate of reaction will increase approximately twice for every increase of temperature by 10 degrees Celsius. Okay, next, so let's look at the experiment 7.3 to investigate the effect of temperature on the rate of reaction. So what we have here for the problem statement is how does temperature affect the rate of reaction. Okay, our hypothesis. So this is our manipulated variables. The higher the temperature of the sodium thiosulfate solution, and our responding variables here, time taken for the S marks to disappear. Jadi relationship dia, the higher the temperature, the shorter the time taken for the S marks to disappear from view. Okay, so yang satu lagi adalah fixed variables. Fixed variables we have volume and concentration of sulfuric acid. Yang ni adalah the second substance that we use in this experiment. Jadi basically eksperimen ni dia lebih kurang macam eksperimen yang masa kita buat concentration. Sebab we are using the same substance which is sodium thiosulfate solution and acid. Okay. Cuma kita fixkan lah concentration of the sodium thiosulfate ni dalam semua set is 0.2 mol per dm cube. Okay, acid also kita fixkan juga concentration and volume of sulfuric acid kita fixkan juga. Okay, 1.0. Then this is the apparatus used. Next, let's look at the procedures.
Draw an X about 2 by 2 centimeters in the center of a piece of white paper. Measure out 25 cubic centimeter of 0.5 mol per cubic decimeter sodium thiosulfate solution using a 100 milliliter measuring cylinder. Pour the sodium thiosulfate solution into a clean, dry conical flask. Heat the conical flask to 30 degrees Celsius. Measure the temperature of the solution with a thermometer. Record the temperature reading. Place the white paper with the X mark on the magnetic stirrer. Place the conical flask on the white paper. Measure 5 cubic centimeter of 0.5 mol per cubic decimeter of sulfuric acid. Pour the sulfuric acid into the sodium thiosulfate solution at one go. Start the stopwatch and magnetic stirrer immediately. View the X from above and stop the stopwatch as soon as the X cannot be seen. Record the time taken for this process to occur. Repeat the experiment using the same volume and concentration of both solutions at different temperatures as shown in the table.
Alright, so the experiment is repeated for 4 times with different temperature from 30 degrees Celsius until 60 degrees Celsius. And then from the experiment, you have to record the time taken for the S marks to disappear from sight. Okay, next is the data and observation.
Record the time taken for the process at different temperatures. Key in the recorded time in the table provided. Well,
Okay, I would like to explain a little bit here. As you can see for the data, when the temperature increases by 10, the time taken becomes shorter. Okay, means the hotter the temperature of the reaction mixture, the time taken also will become shorter. So, the reaction produced in a shorter time. Okay.
based on the results of the experiment, calculate the average reaction rate at different temperatures. Key in your answers into the fourth row of the table. Then click on the check button. Well done.
Okay, kalau kita tengok tadi relationship dia, where the temperature increase, for the time taken will be decrease. Tapi bila 1 over time here, dia adalah directly proportional pula with the temperature. 1 over time also will increase sebab dia 1 over time. So dia inverse balik punya nilai tu.
From the tabulated results, plot a graph of temperature of sodium disulfate solution against 1 over time by clicking on the points on the graph paper.
Okay, dia minta kita buat graph.
Record
Okay, dah siap dah graph kita. So our graph is the temperature of the reaction mixture against 1 over time. So kita tengok tadi relationship dia, when temperature increases, 1 over time also increases, right? So bila kita plotkan dapat macam ni lah. Dapat a straight line graph directly proportional. What is the relationship between temperature and rate of reaction, or the 1 over time? So from the graph, it shows that the temperature of the sodium thiosulfate solution is proportional to the 1 over time, or proportional to the rate of the reaction. So, the higher the temperature, the higher the rate of reaction. Okay, so at last, conclusion dia, hypothesis is accepted. What is our hypothesis? The higher the temperature of the sodium thiosulfate solution, the shorter the time taken for the X marks to disappear from view, or the higher the rate of reaction. Alright, next kita akan sambung terus ke factors number 4 that affecting the rate of reaction is the effect of catalyst on the rate of reaction. Okay, what is catalyst? Catalyst is the chemical substance added during a reaction to change or alter the rate of the reaction without undergoes any chemical change. Change or alter here means it can whether increase the rate of reaction or decrease the rate of reaction. So we have two types of catalyst, namely number 1 is the positive catalyst. So for the positive catalyst, it is a catalyst that increase the rate of reaction and shorten the time required for a reaction to complete. Example, for a positive catalyst, we have manganese 4 oxide. Formula dia adalah MnO2. So this manganese 4 oxide, sebab dia adalah positive catalyst, so it will increase the rate of decomposition of hydrogen peroxide, H2O2. Okay, untuk yang keduanya, type of catalyst number 2 is negative catalyst. So what is negative catalyst? It is a catalyst that lowers the rate of reaction. So the reaction will requires a longer time to complete. And for certain negative catalysts, it can prevent a reaction from occurring at all. Example here, we have phosphoric acid as the negative catalyst because it lowers the rate of decomposition of hydrogen peroxide. So dia vice versa with the manganese 4 oxide. Yang ni positif, yang ni negatif untuk reaction yang sama, hydrogen peroxide decomposition. Okay, next kita nak tengok the characteristics of catalyst. First of all, saya nak recall balik our syllabus periodic table of element. One of the special characteristic of transition element, dia boleh act as catalyst. Jadi kalau jumpa mana-mana catalyst nanti, semua tu datang daripada transition element such as iron, nickel, vanadium, semua tu adalah catalyst. Okay, characteristic number 1, catalysts are very specific. Means it can catalyze a specific reaction. Such as if iron, it is used for the process of Haber. So kalau untuk proses Haber ni boleh guna iron sahaja, tak boleh ganti dengan catalyst lain. Okay, while for nickel, it is used for the production of margarine. Okay. Number 2, do not chemically change. The quantity and the chemical composition of the catalyst remain unchanged at the end of the reaction. Okay, for example, sekiranya kita ada 10 gram of manganese fluoride. Okay, manganese fluoride as the catalyst kan. Jadi lepas siap proses decomposition of hydrogen peroxide, kita dapat balik manganese fluoride tadi. So bila kita timbang balik, the quantity dia masih lagi quantity yang sama. Dan dia masih lagi manganese fluoride. Dia tidak bertukar kepada bahan lain. So itu maksudnya quantity and chemical composition remain unchanged. Okay, number 3. Certain catalysts will physically change. Physical change in terms of color and also shape. Okay, such as if you have manganese fluoride tadi in the form of lump. Okay, ketulan besar. So at the end of the reaction, dapat balik manganese fluoride tapi in the form of powder maybe. So the shape of the catalyst may change lah. Number 4, the catalyst do not change the quantity of the product obtained. It means, okay, let's say you have a positive catalyst. This positive catalyst, it will speeds up the process. Okay, instead of 10 minutes of a process, dia akan ambil masa 1 minit sahaja. Tapi the quantity of the products form, let's say dalam masa 10 minutes tu, dia akan produce 10 cm3 of gas. Tapi kalau dalam masa 1 minit pun, masih lagi 10 cm3 of gas. So dia tidak affect on the products. The amount of the products form does not affected by the catalyst used. Right, and last one. Okay, catalyst only required in a small quantity. So the rate of the reaction will only increase slightly when the quantity of the catalyst used is a lot. So tak payahlah nak guna very big amount of catalyst because it's just affected the reaction slightly sahaja. Jadi masukkan sedikit pun dia dah cukup untuk buat speeds up the reaction ataupun slows down a reaction. Okay, so let's look at experiment 7.4 to investigate the effect of catalyst on the rate of reaction. So we have the problem statement. How does the presence of catalyst affect the rate of reaction? So untuk our hypothesis here, since kita nak kaji the presence of the catalyst, maksudnya kita akan buat 2 sets of experiment. One is with the catalyst and the other one is without the presence of the catalyst, the absence of the catalyst. Jadi hypothesis kita mestilah secara comparison. So the presence of catalyst will increase the rate of reaction. Masih lagi ada MV, presence of catalyst, masih lagi ada RV, rate of the reaction. Tapi tak payah ada pattern, the higher, the lower, tak payah ada. So dia just comparison sahaja. Sekiranya kita nak cakap absence of catalyst will lowers the rate of reaction, pun boleh juga. Okay, vice versa. Okay, our MV, presence of catalyst, responding, rate of reaction. Okay, rate of reaction because we measure time. Okay, we measure production rate of the oxygen gas produced. Sebab the main substance used here is hydrogen peroxide. So kita nak study the decomposition process of hydrogen peroxide. Dia akan produce oxygen gas. Jadi oxygen gas tu produce dalam masa certain time, berapa banyak volume dia, and then in the presence of catalyst, and then yang keduanya in the absence of catalyst, berapa banyak volume of the oxygen gas produced with a certain times given. Okay, so tengok ke procedure.
Observe the video and the reading of the burette for every half minute for 4 minutes for the decomposition of hydrogen peroxide without catalyst. the video and the reading of the burette for every half minute for 4 minutes for the decomposition of hydrogen peroxide with catalyst.
Okey, eksperimen dah siap.
Observe the video.
Next, kita tengok how to interpret the data from the experiment just now. Yang kita ambil adalah burette reading. Time are given for total 4 minutes. Then burette reading are recorded for every 30 seconds or half minutes interval. So let's say from minute 0 to minute 0.5 every 30 seconds dia akan ambil bacaan lah burette reading. Jadi untuk kira total volume of gas collected, burette reading ni initialnya adalah 50. So pada masa 50 ini volume of gas masih lagi kosong, tolak dengan 50 juga. Then for the next 30 seconds, burette reading dah shows 49.9. So nak tahu dia punya volume of gas, just minus with the initial burette reading 50 minus dengan yang current 49.9, dapatlah volume gas yang dia produce kat sini. So buat calculation and so on sampailah ke minute 4, dapat volume untuk oxygen gas produce. Yang ni without catalyst. Dan ulang lagi sekali calculation untuk total volume of gas produce. Yang ni with catalyst. Then kita akan plot graph.
Based on the data collected for both experiments, calculate the total volume of gas released at every half minute. Plot the graph of decomposition of hydrogen peroxide with catalyst. Plot the graph of decomposition of hydrogen peroxide without catalyst.
Okay, dah siap plot both graphs. So we are going to compare the graph
Based
of volume of oxygen gas produced against time. So both kita gunakan time adalah until 4.0. Yang ni graph with catalyst, while this one is graph without catalyst. So as you can see here, at minute 4, the production of the oxygen gas used yang diproduce adalah 13 point something. Okay, while for the reaction that not use catalyst, at minute 4, the production or the volume of oxygen gas is 3 cm3. Okay, so as the discussion for this experiment, number 1, in the presence of manganese fluoride as a catalyst, hydrogen peroxide decomposes and release oxygen gas. Oxygen gas release relights the glowing wooden splinter. Maksudnya kita nak test the presence of gas yang diproduce, kita boleh test with the glowing wooden splinter and it will relight. So this is the chemical equation for hydrogen peroxide H2O2 when decomposed. Mesti tulislah patutnya kat atas ni, in the presence of manganese fluoride MnO2, it will produce H2O, water, and also oxygen gas. Okay, kalau tak ada manganese fluoride pun, dia akan produce juga, cuma in a slow reaction lah. Without manganese fluoride powder, decomposition of hydrogen peroxide occurs, but very slowly. Tengoklah data tadi yang dia compare at minute 4, yang tu just 3 cm3, while at minute 4 untuk yang catalyst ada 13 point something. So the rate of decomposition of hydrogen peroxide increases with the presence of catalyst manganese fluoride powder. And then the mass of the manganese fluoride does not change after the reaction. So bila kita timbang balik, kita akan dapat the same mass yang kita added in the initial reaction. So this shows that the manganese fluoride does not experience any chemical change. And lastly, tapi secara fizikalnya it might change. The color of the manganese fluoride change from brown to black. Okay. So last conclusion, hypothesis is accepted. Presence of catalyst will increase the rate of reaction. Alright, so kita dah habis ke empat factors. Kita nak summarizekan what are the factors that can increase the rate of reaction. Okay, cuba kalau increases rate of reaction, dia mesti number one, concentration of reactant must be increases. Increase concentration, increase rate of reaction. Yang kedua, size of solid. Okay, size of the solid reactant must be smaller or decreases. Barulah rate of reaction increases. Okay, number three, temperature. Temperature of the reactant mixture must increases, higher temperature. Barulah rate of reaction increases too. Then lastly, is the presence of catalyst. Presence of catalyst will increase the rate of reaction. Okay, so you can use the acronym CSTP to help you to remember the factors that affect the rate of reaction or the factors that can increase the rate of reaction. Concentration, size, temperature increases, presence of catalyst. Okay, now let's look at the chemistry lens. Pressure is another factors that affect the rate of reaction. Okay, however, kena ingat yang pressure ni dia just affect the reaction that involving gaseous substance. So kalau dia adalah solid, tak boleh lah pressure ni adalah factors that affecting the rate of reaction dia. Ataupun substance dia dalam bentuk liquid, tak adalah factor pressure tu mempengaruhi. So pressure ni sekiranya ada substance yang dalam bentuk gas and gas. Sebabnya, okay, contoh, you have a certain volume of gas here, let's say 10 cm3 of gas. Bila kita compresskan container ni, volume dia dah become half, become 5 cm3. Jadi particles ni masih lagi at the same number, maintain lah. Jadi bila volume of the container become decreases, the particles do not have much space to move. Jadi it has a smaller space, maka akan berlaku collision lagi kerap. So the higher the number of collision, the higher the rate of reaction also. Okay, so itu untuk pressure lah. Okay, so sebelum saya nak bagi latihan 7.4 ni untuk awak, let's look at example 2, 3 and 4 together in your textbook. Okay, this is example 2. Reactive metals such as calcium react with water to produce hydrogen gas. Okay, these are the equation. Jadi, apa maklumat yang kita ada? Given mass of calcium 0.7 and 200 cm3, volume of water, different temperature. Okay, saya nak annotate sini. Kena highlightkan perkataan different temperature ini. Sebab this is the factors that affecting the rate of reaction, temperature. Dan dia kata eksperimen 1 ni dia buat at room temperature. Eksperimen 2 ni dia increasekan by 10 degree Celsius. Tapi temperature of water lah yang solution. Kalau yang calcium ni tak boleh lah factor the temperature. Calcium ni mungkin factor dia adalah surface area lah pula. Okay, so the graph shows the volume of hydrogen gas against time for experiment 1 ini. Okay. Soalan A, what is the total volume of hydrogen gas produced in experiment 2? Soalan ni melibatkan calculation lah sikit. Okay, untuk eksperimen 1, dia cakap dia dah producekan 420 cm3 of hydrogen gas. Mana kita tahu dia dapat 420 ni? Daripada, ini maklumat dia tadi, 0.7 gram of calcium. Okay, untuk hydrogen gas produce, kita kena tengok pada reactant use. Reactant, if calcium 1 mole, tak ada nombor kan kat depan dia, so this is 1 mole. Hydrogen gas also 1 mole. So saya ambil yang ni. This is stoichiometry equation. From equation, 1 mole of calcium produce 1 mole of hydrogen gas. Okay, next. Now kita nak cari number of mole of calcium sebab kita ada maklumat 0.7 is the mass. Jadi masukkan mass 0.7 divide dengan molar mass. Calcium kalau tengok dekat belakang of your textbook, relative atomic mass for calcium is 40. Jadi awak akan dapat 0.4 divide by 40 is 0.0175 mole. Baru number of mole. Jadi kita kata number of mole for hydrogen gas also 0.0175 lah, right? Sebab dia same ratio. Jadi nak cari volume of hydrogen gas ini mestilah number of mole that times with molar volume. Molar volume kita nak ambil pada room temperature. Dia dah mention room temperature, which is number of mole dia 0.0175. Bila awak times with the molar volume 24 lah kalau untuk room temperature. So awak akan dapat nilai dia 0. Yang ni unit dia adalah mole, ini unit dia adalah dm cube per mole. So unit awak dapat nanti adalah dalam unit dm cube 0.42 dm cubic ataupun 420 cm cubic. Okay, jadi kita nak tahu whether in experiment tu the volume of hydrogen gas produced sama ke beza. So tengoklah dia bagi tahu 2 experiments carried out at the same 0.7, masih lagi same number of mole of the calcium. Jadi kita expect the volume of the hydrogen gas produced also the same. So reason awak, the same mass of calcium are used. Jadi the same number of mole of hydrogen gas is produced. So the volume of the hydrogen gas produced also the same. Sama je lah ni, 420 cm3. Cuma copy the graph above and sketch the curve for experiment 2. Untuk experiment 2, since apa yang beza dengan experiment 1, dia adalah yang ni pada room temperature, yang satu lagi slightly higher. Room temperature 30 dia mesti dalam 40 degree Celsius. So dia punya graph agak steeper ke less steeper? Should be steeper. Okay, sebab faktor dia adalah temperature lagi higher. So steeper macam ni lah, ke atas daripada experiment 1. Tapi dia mesti bersambung. At the end dia mesti bersambung pada graf yang sama juga. Sebab masih lagi production of the hydrogen gas is 420. Cuma dia lagi steeper. So jangan lupa bila kita sketchkan graph, you have to label your curve. So this one is for curve 1, this one is for curve 2. Okay, and question C, what's the effect of temperature on the rate of reaction? Increase by 10 degree means the higher temperature, the higher the rate of reaction. Alright, okay, next. Okay, next is example 3. Gastric is caused by the production of too much acid in the stomach. So doctors use antacid tablet. So dalam antacid tablet ni dia ada antacid tablet reacts completely in excess hydrochloric acid under different condition. Oh, antacid tu akan react dengan hydrochloric acid in our stomach lah. HCl ni dalam gastric juice. Tapi in different condition. So untuk eksperimen 1 kita buat 50 cm3 with 1.0 mol per dm cube. temperature 30, time of reaction is 120 second, barulah complete reaction. Okay. Bila eksperimen tu, yang bezanya, yang ni 50, yang ni adalah 2.0. So dia doublekan concentration of the hydrochloric acid. Okay, concentration double, rate of reaction also must be double. Jadi time taken ni akan jadi separuh, shorter. Maksudnya higher rate of reaction dia, walaupun temperature dia sama. Okay, while for experiment 3, concentration yang sama, cuma beza dia adalah pada volume. Jadi apa beza dengan eksperimen 2? 2 and 3 ini dia akan different products form. Yang ni dia akan bagi number of mole, sebab number of mole is equals to concentration that times with volume. So number of mole this one, berapa number of mole dia? Okay, kalau number of mole, MV over 1000 1.0 times dengan 50. Ini adalah 0.005. Nah, ini number of mole dia 0.005, this one. Kalau untuk yang ini, number of mole dia 2.0 times dengan 100. 0.2. Cak, tadi betul kan? 2 times dengan 50. Oh, ni 0.1. Zero point zero one, 0.10, ini 0.20. Okay, kalau number of mole yang eksperimen number 4 sama dengan number of mole eksperimen number 1 ini, which is 0.10 juga. And then eksperimen untuk set 1 ini 0.005. Okay, ini adalah number of mole untuk setiap hydrochloric acid used. Okay, ini adalah temperature dia. So untuk eksperimen 3, dia akan produce number of mole double than eksperimen 2. Jadi kalau kita tengok graph, number of mole ni dekat belakang ending of the graph. Tapi temperature sama. Jadi time taken pun sama juga. Okay, let's say kalau kita plot graph, dia akan jadi macam ni. Okay, for eksperimen 1. Okay, contoh. Eksperimen 1, 0.005. Paling lower lah rate of reaction, dah lah concentration dia 1.0. Dan temperature also 30 degree Celsius. So, kita nak draw untuk eksperimen 1 ni, macam ni je. Okay, landai je. Okay, while for eksperimen 2 ni, dia dah berubah concentration double. Jadi, untuk concentration yang lagi higher, reaction mesti lagi ke depan lagi, maksudnya lagi steeper. Number of mole pun double juga, 0.005 dengan 0.1. Jadi dia lagi tinggi lah production dia. Okay, kat sini reaction 2. Okay, for experiment 3, concentration sama, temperature also sama. Jadi untuk eksperimen 3 ni, saya guna color lain. Dia masih lagi akan produce, dia akan produce graph yang sama. Tak jadi dah. Tak boleh. Okay, belah sini lah. Di atas sini. Cuma saya akan sambungkan initial dia pada graf yang sama. Okay, maksudnya dia tidaklah steeper than the reaction 2. Dia tidaklah less steep daripada reaction 2. Dia bergerak sama initial of the rate of reaction dia, tapi at the end of the reaction dia produce lagi banyak hasil sebab dia adalah 0.2, yang ni 0.1 sahaja. So rate of reaction for experiment 2 dengan 3 ini sama. Okay, while for experiment 4, since concentration sama, tapi lebihnya pada experiment 4 ini dia guna higher temperature. Tapi number of mole dia akan produce sama with the experiment 2. So mana experiment tadi? Ini 1, ini 2, ini 3. Experiment 2 is here. Tapi dia lagi steeper. Lagi kat depan lagi. Lagi steeper. Tapi at the end dia akan bersambung kat sini. Bersambung dengan eksperimen 2. So inilah graf kita. This is for graph 1. This one is for graph 2 untuk yang merah tu. Dan ni yang paling tinggi adalah graph 3. Dan yang paling steeper ini adalah graph yang eksperimen keempat, number 4. Okay. So, kalau awak sketch, awak akan dapat graf macam ni lah. Okay, so soalan, why is the time of reaction is different for experiment 1 and 2? Jadi kita tengok apa factors that affecting the reaction 1 and 2. Yang bezanya adalah concentration. So concentration for experiment 2 is double, higher concentration. Okay, twice concentration than the experiment 1. So that's why lah time taken pun dia akan jadi berkurang separuh, lagi cepat. Double cepat dia. Okay, B, which of the following experiment shows the change in volume of hydrochloric acid does not affect the rate of reaction? So volume yang berubah yang ni. Which of the following experiment? So experiment 3 that shows the change in volume of hydrochloric acid does not affect the rate of reaction dengan experiment 2. Eksperimen 2 dia sama-sama sebabnya kita akan tengok pada rate of reaction, same concentration dan juga temperature, same temperature. So that's why eksperimen 2 and 3 ini dia berjalan seiring sejalan. Cuma beza dia pada products form at the end. Cuma rate of reaction sama. So does not affected by the volume of hydrochloric acid. Okay, C. Why is the rate of reaction for experiment 4 higher than experiment 2? Tengok factors lah. Apa factors yang affecting the rate of reaction for experiment 4? Concentration. Sama concentration. Experiment 2 also used to. Experiment 4 also used to. Tapi yang bezanya adalah temperature. Yang ni use 30 degree. This one used 40 degree. So 40 degree dengan 30 degree. 40 degree lagi higher temperature. So experiment 4 has a higher temperature compared to experiment 2. Okay, other than temperature and concentration of the hydrochloric acid, what changes can be made to increase the rate of reaction in experiment 1? Okay, kita nak buat apa lagi untuk increasekan the rate of reaction? Concentration dah mention, temperature also dah mention. Catalyst tak semua reaction boleh use catalyst sebab dia adalah very specific. So kita tengok pada surface area. So these are the reaction between antacid and also acid hydrochloric ni. Jadi acid ni dalam bentuk solution dia boleh affected by temperature and concentration sahaja. So sekiranya antacid ni dalam bentuk solid form, so kita boleh gunakan factors size ataupun surface area. So mungkin antacid dalam tablet tadi tu kita tukarkan kepada powder punya antacid ataupun kita use a smaller size of tablets maybe untuk increasekan the rate of reaction in experiment 1. Okay, dah habis untuk example 3. Seterusnya kita akan tengok pada example 4, which is kalau tengok example 4 itu dia adalah factors presence of catalyst. Okay, example 4. Adnan carries out an experiment to investigate the decomposition of hydrogen peroxide, H2O2. He records the volume of oxygen gas at 5th minute. Barulah ditambah with the catalyst. Ni catalyst dah ni. Full of black powder into the hydrogen peroxide solution. So, kita dah tahu black powder ni adalah manganese 4 oxide. Okay, manganese 4 oxide. So the diagram shows the graph of the volume of gas against time. Dia tiba terus naik. Naik terus dia punya volume of oxygen gas produced. Maksudnya, apa effect of the black powder on the rate of reaction? It is increase the rate of reaction. Naik dengan double, triple-nya terus. Okay, so what is the function of the black powder? Act as the positive catalyst. Kalau nak minta name pun boleh namakan dia adalah manganese 4 oxide. Okay, so saya nak awak cuba jawab soalan activity 7.4 dalam textbook ini. Bolehlah nak hantar melalui WhatsApp. Screenshot jawapan, hantar WhatsApp secara personal. Saya akan check lah sorang-sorang. Dan for your weekend work, please answer test yourself 7.2, textbook page 239 and upload your work in Google Classroom. Untuk test yourself ini, saya akan ambil masa lain untuk discuss. Test yourself 7.1 pun belum discuss, 7.2, 7.3 and 7.4 insyaAllah. Alright, thank you and have a nice weekend ahead. Bye.